Okay, dear students, let us see what is there in this question. Two capacitors of different capacitance are connected in series. So this is C1, this is C2, they're connected in series to a source of EMF of negligible internal resistance. What is correct about the potential difference across each capacitor and the charge on each capacitor? Okay, so my dear student, this question is about the combination of the capacitors. So we know that whenever two capacitors are in series with each other, the charge is same on them. That is basically the definition of a series combination. So two capacitors are known to be in series combination if the charge on them is the same. Got it? So definitely the charge here will be Q, here will be Q. So what actually happens here is there is a bit of irony involved here. Be very careful. So this becomes positive, this becomes negative, this is positive, this is negative. So the charge on this is Q, charge on this capacitor is also Q. So if I ask you, what is the total charge which is coming out of the battery? What is the charge which is withdrawn from the battery? What will be your answer? So in the first instance, people will say 2Q because there are two capacitors and both are charged. But my dear student, the answer is Q. So Q is the charge which is coming out of the battery. Q is the charge which is created on the capacitor number 1, and Q is the charge which will be created on the capacitor number 2. But how so? Why so? Like, how can this be? Because the charge that has left is only 1, and the capacitors are having two capacitors are having charge Q. How is that? Try to understand when this charge comes from here, the first plate becomes positively charged, and we can just assume that the negative charge is going to this side or the positive charge is going this. So this plate will become negative charge, this plate will become positive charge. There is no doubt about that. This is okay. Now, if this plate is having positive Q charge, it starts induction. So induction happens, and on this plate negative Q charge is created by the plate itself, and this charge, on contrary, it creates positive charge there, obviously. So that is positive Q. So this positive Q charge here and the negative Q charge here is because of induction. So that charge is not going from the battery, it is because of the induction. The plate is already, like, it is neutral, so it is already having positive charge and the negative charge. Only because of the induction they are now segregated separately. So one plate is having positive charge, another plate is having negative charge, and that is happening due to induction. This is the process of charging. So this is how the charging happens. And whenever we say what is the charge on a capacitor, we do not say that positive plate is having positive charge and the negative plate is having negative charge. We only consider the charge on the positive plate. So this capacitor is having charge Q, and we are neglecting the charge on the negative plate. Similarly, this is also having the charge Q, and the negative charge is neglected. Capacitance here is C1, capacitance here is C2. So the point number one is that charge is definitely going to be same. There is no doubt about that, because this is a series combination. In parallel combination, the potential difference is the same, but the charge is not the same. Q1, Q2. Okay, so this thing is done. Now let us go for the second thing, which is potential difference. What about the potential difference? Obviously this is the series combination, and the potential difference across this will be V1, and across this it will be V2. So V1 and V2, these are two different potential differences. How can I say that? Number one, because they are in series, so V will be V1 plus V2, and we write it like this, and Q is equal to CV. So Q1 is equal to C1 into V1, and Q2 will be equal to C2 into V2. So now we say that charge is same. If charge is same, obviously when capacitance is not same, potential cannot be same. It will be 2 multiplied by 3, and here it could be 3 multiplied by 2, somewhat like that. So the potential is also not going to be same. So potential will be different. So your answer will be C. Do you get my point? Because charge is going to be same, the potential difference is not same because the capacitors are not same. If they were having the identical capacitors, then what? Then even the potential difference will be same. The capacitance will be same, the potential difference will be clearly half of what it is. Like V is the EMF, it will become V by 2 and V by 2 on each of the capacitor. So this is how we do this question, my dear student. If there is any problem in the explanation and you are not able to understand it properly, please do mention it in the comment section, and I would be re-uploading the videos as per your demand. No worries at all. Okay. And so this is how we do this question, my dear students. And this is Professor Varun. Please subscribe to the YouTube channel. And if you want to access the paper two questions, you have to join the YouTube channel. All the best. Bye.